Dear participants, we will be starting the session by 2:15. Good afternoon, all the participants. Today, among ourselves, we have Mr. Yogesh. Good afternoon, sir. Mr. Yogesh is working as a lecturer for last 15 years in KK Wagh Polytechnic, Nasik. His area of work is teaching English and communication, soft skill, management skill, and entrepreneurship development, literature, and content writing. He has conducted many trainings for students as well as for faculty on soft skill, communication skills, spoken English, teaching of English, entrepreneurship development. He is a practitioner of Sahajayoga since last 15 years and conducted many trainings for youth empowerment. So I request Mr. Yogesh to kindly take over the session.
Yes, thank you very much for dear participants. I hope I am audible.
Yes, sir, you are audible, but little your voice is less.
I'll try to improve. All right.
Yes, sir, better.
Yeah, thank you. Before I share my presentation, let me thank all organizing of thank all her team members. Because talking about meditation in a technical session, of course, has its own importance, as we can see that we all are surrounded by some or other technology, and that has become the reason behind sometimes the kind of stress we face. And at that level, we need to practice some certain things like meditation, which help us to get away from meditation, get away from the technical issues, technical burdens that we face in our day-to-day kind of situations, and that also helps us to balance our lifestyle at various levels. So in today's session, we'll have a few things like what stress actually is, how we can overcome it with the help of regular meditation, what are the benefits of regular meditation, and how we can enhance our qualities at personal and professional life with the help of meditation. There would be two parts here. Initial part would be a theoretical part, and just so in today's session we'll have first part on basic information about all these things, and the most important thing would be the practical experience of meditation. We'll practically try meditation here. So Ashish sir has also joined. I request Ashish sir if he can continue with the first initial part of the introductory part of meditation, and then we'll go for practical part of it. Ashish,
Okay.
Good afternoon, Ashish, sir.
Yes, I have joined, ma'am.
Yeah. So all participants today among ourselves, we also have Mr. Ashish Kumar. He is also working, he's a senior manager in Hindustan Aeronautics Limited, Nasik, and has a wide experience of more than 18 years at there. He is also involved in setting up of Sukhoi 30 fighters aircraft project facilities at HAL, and worked in the transfer technology from Russia for armaments, hydraulics, and pneumatic pressure for MiG and Sukhoi series of aircrafts. His experience of assembling in these aircrafts, fault finding and diagnosis of these aircrafts. He is also involved in the training of employees for motivation and conflict management, and has conducted many trainings on Sahajayoga for the students as well as for the faculties. So I welcome you, sir, and I request you to both of you to please kindly take over the session.
Thank you, ma'am. And first of all, I would like to welcome you all over here. And today's session, as Yogesh sir has explained, we'll go to practical part also. So the first, during the initial part, we will learn what is stress, what is and why Sahajayoga, and how to get balance through the meditation, how our professional while will be improved, whether it will be really improved or not, and the practical experience. And at the end of the session, we will go for question and answers. So what is actually Sahajayoga is, and where do we need meditation? Because in today's circumstances, we are all facing various challenges. I'm just 1 minute. The time for today's session is 2:32 uh, up to. It is for 1 hour or 1.5, ma'am.
1 hour, sir.
Hello, 1 hour, no?
Hello, Anji, 1 hour.
Yeah. So we are facing different types of competitions are there. We have different career objectives. Our parents' aspirations are there that they want us to be at a higher level, earn better, and live in a good society. These kinds of parent aspirations are there. Along with that, there may be health, physical problems are also associated with our body, and negative thoughts come due to the circumstances that surround us, like COVID is there, competition is there. So these all kinds of things gives us negative thoughts. Um day day by day, the society is becoming weak. Our what social sphere is becoming weak, because in earlier days we were having good friends. Yeah, if you can see our older generations, they were having very good nice friend, nice society, and day by day the values of the relationship is going down and down. So all these things gives us negative thoughts, depression, and all these things also gives us a kind of stress. And the stress is actually, it is not shown on the face of the person, but it is inside. Person may be happy, may be showing happiness over his part of life, but maybe he is stressful. And coming out of those stressful situation is a very important part nowadays. So in that case, we need definitely the meditation part, because meditation not only balances you physically, but it also balances you mentally. Uh, and internally you become strong day by day as you go into meditation. There are various different myths about meditation that we will come to know in the latter part of the session. So we actually really need meditation, but we have some fears about meditation. And sometimes it happens that we are actually not aware what meditation is, what amount of time it will be required, and whether we are also not sure whether it will really help us to come out of the stress, whether really it will be helpful for our physical well-being and mental well-being. So in today's session, we will clear all these questions. We will cover these questions, and we will come to know that really meditation will be helpful for all those things. Next slide, please. So Sahaj Yoga is a unique discovery of modern times by Sri Mataji Nirmala Devi. Sahaj Yoga, as the name suggests, is the inborn. Sahaja means inborn, and yoga is the union of the self with the all-pervading power, which is known by different name as God, cosmic energy, nature's energy, and various names of the different gods, whatever you want to say. Actually, there is a divine energy that is situated within all of us, and when this energy gets awakened, it gets connected with the nature's energy, cosmic energy, whatever may be the name you have given. So basically we are all one and the same, created by one almighty. And uh, we may have given different names, but Sage Yoga as such respects all the religions. And there is a awakening of this energy when we go for meditation. So Sage Yoga is a very simple way of joining with the nature's energy or the divine energy. What actually meditation is, because of the thought process, we are all continuously bombarded by thoughts. One thought goes, another thought comes, another thought goes, another thought comes, and there is no gap between the two thoughts. Due to this process, what happens that we are not actually in the present. Like you are now listening to this lecture, but you may be thinking, what about at home? What about at evening lunch? What are the activities that you may have planned in the evening, or maybe tomorrow, or maybe 1 month after? You may be thinking different things. So what happens that due to this thought process, you are not actually in the present, and you are thinking either of the past or of the future. And due to this, there is no gap between the two thoughts. But due to the rising of the or the awakening of the divine energy that is known as kundalini within us, it what happens that the agya chakra that is situated in the forehead area, it becomes open, and it happens that there is a gap of some seconds, or after some days it becomes a gap of minutes uh, between the two thoughts. And it happens automatically from within us. You don't have to do anything. And once one thought goes, then there is a gap of some time. After that, another thought comes. This is the way meditation brings you in the present time. Now we can see there is a short video how this meditation helps you to come into the present tense or into the thoughtless state.
ध्यान कितना आनंददायी अनुभव है, पर जो बाहर से शांत दिखता हो, क्या वो अंदर से भी उतना ही शांत होता है? हमारा मस्तिष्क एक अंडे की तरह है, जिसमें अनगिनत क्षमताएं हैं। अगर सही मायने में ध्यान हो रहा हो, तो हम वर्तमान में रहकर सत्य के प्रकाश में आलोकित हो जाते हैं। मगर आम तौर पर ऐसा नहीं होता, क्योंकि अतीत और भविष्य के विचारों के बादल इस प्रकाश को ढक लेते हैं। हम इन्हें रोकने की कोशिश करते हैं, मगर जैसे ही हम एक विचार से छुटकारा पाते हैं, हम दूसरे विचार में उलझ जाते हैं। ये सिलसिला चलता ही रहता है और शांति पाने के बजाय हम थक जाते हैं। ध्यान असंभव लगने लगता है। लेकिन अगर हम बिना कोई प्रयास किए इन विचारों से छुटकारा पा सकें, तो क्या आप इस सहज ध्यान का अनुभव करना चाहते हैं? तो आइए सहज योग ध्यान करें, जिसकी शुरुआत कुंडलिनी शक्ति के जागरण से होती है। एक बार ये शक्ति जागृत होने पर हम विचारों से परे हो जाते हैं। क्रोध, लोभ, भय आदि के बंधन से मुक्त हो जाते हैं। हमारा मस्तिष्क इस ज्ञान के प्रकाश में विकसित होने लगता है। हम सही मायने में स्वतंत्र हो जाते हैं। आइए सहज योग ध्यान के आनंद का अनुभव करें।
As shown in this video, you can see that this thought process gets stopped due to awakening of this knowledge. Now we will move towards our subtle system. There are 7 energy centers situated inside our body, and there are 3 nervous systems inside our body. These energy centers are situated inside our spinal cord area. As you can see, there are 7 energy centers, and the same are represented into the person sitting over here. You can see in the diagram. And these energy centers have their positions on hands also. These 7 energy centers are nothing but actually the bunches of nerves that come out of from the spinal cord area. There are 7 energy centers, and they are controlling different organs of our body. Like I will give the example of the 3rd energy center, that is Nabhi chakra, shown as green in color. It is actually controlling the total digestive system, like stomach, intestines, and large intestine, small intestine, and all the liver, some part of the liver. So this energy center is actually responsible for total digestive system, working of the total digestive system. At the same time, it gives you the feeling of peace, contentment, and dynamism from inside. So these energy centers are responsible for physical work also, and at the same time, they are also responsible for some qualities inside our being. These are represented in the form of points on our hand also. Apart from this, there are three energy systems. Like you can see the left channel, known as in blue color, uh, which is responsible for the past tense, and it is showing it gives us the feeling of emotions, or the all the mental processes. Our emotional being is represented by the left channel. It gives us the thoughts of the past also. This nervous system gives us the thoughts of the past. Now another nervous system is there, which is known as right sympathetic nervous system, or the right channel, and it is represented in yellow color over here. It gives you uh, the uh, thoughts of the future. At the same time, it is uh, responsible for our physical being, means our physical fitness, and all the things are taken care of by this nervous system. Then there is third nervous system called as the central channel, or the central nervous system, or autonomous nervous system. Situated on this nervous system are the 7 energy centers, and it looks after those functions of the body that are not in our control. Like our pumping of the heart is there, blood pressure is there, then respiratory system is there, digestive system is there, excretory system is there. These processes are not controlled by our body, they are automatically happening. uh, whatever time you may eat something, the digestive process start, and it is automatically digested, whether you eat sweet, whether you eat sour, whatever it may be. In the same way, wherever you go, the oxygen is taken inside the body and carbon dioxide is thrown out. Oxygen is conveyed to all the cells of our body. So it is happening automatically. We don't have to do anything, and it is controlled. It is not. We are not able to control these things. So there are 7 energy centers and 3 channels inside our body, looking after the various body functions. Apart from that, there is one energy called as Kundalini that is situated at the end of the spinal cord in a triangular bone called as sacrum bone, and it is in the form of coils. So it is, the name given is Kundalini. This energy is in sleeping state. This is because when this energy enters when we are in the mother's womb, around 3 months old. At that time, it enters. It converts all the stem cells into the body organs, nourishes them, creates all the organs of our body, and then goes into the sleeping state, or the dormant state, we can say. And uh, uh, as she is in sleeping state, we are not aware of it. When we do meditation, when we go for meditation, what happens, it comes up. That is shown in the that you will be able to see in the next slide in the form of a video. So when you go for meditation, you do meditation, you there is Kundalini energy that is residing within us, or in the sleeping state. It tries to rise. It comes to different energy center. As you can see in this diagram, in this video, that when this energy is rising, it is nourishing each and every chakra. It gives energy to each and every chakra. As she has created each and every cell of our body, when we were in mother's womb, it knows how our different channels or different chakras are functioning, whether they are functioning in a correct way or in a bad way. So it tries to clear the hurdles that are obstructing the function of the chakras, obstructing the function of our organs. So it goes to different chakras. It clears, like it has cleared now the second chakra and the third chakra. It clears. At the same time, it gives you the feeling of the peace and contentment. Um, those which are the qualities of those chakras, and at the same time it clears the organs within our body. So, and it is indicated in the form of hot or cool breeze on the on your hands and on your head area. It also balances the left and the right channel, and it brings you in the present tense because of the opening of the Agya chakra that is open. So uh, there is, you are able to control your thought process, and once we are able to control our thought process, what happens is we are able to see the situation clearly, we are able to come out of the stress. So we'll now move to the next part, uh, is the practical experience of it. Uh, in the practical experience part, what we need to do is we do not need to sit on the ground, or we do not need to sit on ground. We can sit on chair. We have to follow only the three steps, and when we are doing these three steps, we need to close our eyes. First of all, I will explain these three steps. You first see those steps, uh, and then we will practically perform them. So the first step, we have to sit on chair. We can sit on chair, then put your right hand on left side of your body where your heart is situated, and we'll pray one prayer over there. After that, we will put our hand on our forehead area. Then we will do another prayer. And the last part of the process is to put hand on the head area, on the fontanel bone area, on the top of the head, as shown in step 3. Here, just press slightly by your hand and move the hand in clockwise direction, just so that it will slightly press and move your head area. Okay, so these are the three steps. You can sit like this person is sitting on chair. Put your both hands in your lap, and when I will tell you, then at that time you close your eyes, and till the time I tell you, you should not open your eyes. This is the only thing that you have to do. And remember one thing, just do all the steps by full heart, even though you miss the steps or you do them in a wrong way, nothing will happen. uh, Only thing that you have to do is to do all the steps with full heart. Okay, so now we will perform them. So first of all, you can see the photograph of Sri Mataji, who is the founder of the Sahajayoga meditation, and uh, we will pray to her, and I will take the name of Sri Mataji when we will perform the prayers. At that time, you can take the name of God, you can take the name of Allah, you can take the name of Guru Nanak Ji, you can take the name of Jesus Christ. If you find it difficult to take Sri Mataji's name. Okay, so only three steps are there. First step is to put your right hand on your left side of your body where heart is situated. Then put your right hand on your forehead area. Last step is put a hand on top of head. Move it 7 times. Then take it away from your body. Take it away from your head, 4 inches, 5 inches up. Then bring it back closer to your head. Again, move it away from your head. So these are very simple steps that we will be able to do. Okay. So now we'll start the practical part. Open your eyes, see Sri Mataji's photograph clearly. And here we will pray, Sri Mataji, kindly give me my self-realization. Sri Mataji, kindly give me my self-realization. Or you can say, oh God, Please give me my self-realization. Now we will close our eyes. I request all of you to close your eyes before your attention moves outside, and do not open your eyes until I tell you. Now put your right hand on left side of your body where heart is situated and say the prayer, Shri Mataji, I am pure spirit. श्री माता जी, मैं शुद्ध आत्मा हूँ। श्री माता जी, मैं शुद्ध आत्मा हूँ। मैं शुद्ध आत्मा हूँ। मैं शुद्ध आत्मा हूँ। Or you can say, Oh God, I am pure spirit. हे ईश्वर, मैं शुद्ध आत्मा हूँ। Now put your right hand on your head area, forehead area, on your forehead area. Here we will pray and forgive each and everyone. Please pray and say inside your mind, Shri Mataji, I have forgiven everybody, including myself. Shri Mataji, kindly forgive me. Shri Mataji, I have forgiven everybody, including myself. Shri Mataji, kindly forgive me. हे ईश्वर, मैंने सबको क्षमा कर दिया। मैंने खुद को भी क्षमा कर दिया। कृपया आप भी मुझे क्षमा करें। Now put your right hand on top of your head. Last step. And we will pray, Shri Mataji, please give me the experience of the self-realization. Shri Mataji, please give me the experience of self-realization. श्री माता जी, कृपया मुझे मेरे अंदर स्थित ईश्वरीय शक्ति का ज्ञान और उसका अनुभव मुझे प्रदान करें। Say it with full heart, श्री माता जी, मेरे अंदर स्थित ईश्वरीय शक्ति का ज्ञान और उसका अनुभव मुझे प्रदान करें। Now move your hand in clockwise fashion by putting it on top of your head area. Don't move your head, just move your hand 7 times. After completing the 7 times, slowly take your hand away from your head. Slowly move it away from your head. You will feel cool breeze is coming out from the top of your head area towards your hand. Take it away, again bring it back and keep it on your forehead area. Again move it away from your top of your head. You will feel cool or hot breeze coming out from top of head or from your fingertips or from your right hand. Now put your right hand in your lap. Now check with left hand. Put left hand on top of head and move it away from the head area upwards. And Slowly move it up, move it down. You will feel cool breeze is also felt on cool breeze or hot breeze is also felt on left hand. Now put your left hand in your lap. Keep your eyes closed. Keep your both hands in your lap, palm facing upwards. You will feel hot or cool breeze coming out from the center of your palms, from the tip of your fingers, and from the top of your head area. Now try to observe the thought. You will feel that no thoughts are coming at all. Even though they are coming, there is a gap of some seconds between the two thoughts. You can think as per your wish. If you try to think, you can think. If you want to stop it, you can stop. A feeling of joy, peace, and contentment comes within us. You will feel no thoughts are coming. Cool or hot breeze is coming from your hands, top of head. A feeling of relaxation is there. Now slowly open your eyes. You will feel that you should not open your eyes. You are feeling so contented, joyous, and peaceful from within. Still try to open your eyes. So in the latter part of our session, we'll request you to share your feelings and your questions, how you have, and question how you have about how you have felt while during doing this practical part of the session. Now we'll move to the next part of this session. We have now awakened the energy within us, that is Kundalini. Now I request Yogesh sir to continue with the meditation benefits.
Yes, thank you very much, sir. Before we go to this section, if some participant would like to share his or her experience of meditation, can you please unmute and share the experience, whatever you have felt on both the palms or top of your head, fingertips? Is there any participant who would like to share his or her experience? Yes. Will I allow you to unmute? Yes, you can unmute yourself, and if any participant would like to share some experience of meditation, whatever you have felt on the top of your head and even both the palms, fingertips. Because meditation is like a practical experience. Whatever we are going to discuss here, unless and until you get that feeling, unless and until you experience that, this discussion will be not so beneficial. And that is what we want. We want to keep this discussion interactive one, so that your experiences are important. Whatever we try here, you must be able to experience that. That is what our aim is. So if any participant would like to share experience. We just did it for not more than 2 minutes, and probably you might have felt cool or warm sensation on both the as well as the tips. And even some of you might have felt it on the top of your head. So when we get this kind of feeling, what and how it should help us, or rather, with the help of this feeling, you can check which of your energy centers, they are known as chakras, as Ashish sir has explained. That these chakras, energy centers, they tell us which part of body or what part of your being is not working properly or is working properly. That can be judged properly. We'll discuss it further also. But let me tell you some benefits that we have. Like mostly when meditation, we do regular meditation. You can do it morning and evening, 10 minutes at least. And this regular meditation will help you to get some health benefits. As we know the definition of health by WHO, it includes not only physical health, it also focuses on mental well-being and even the emotional part of it. So emotional stability, or in today's world, we call it as emotional intelligence. Getting emotional intelligence, being mentally stable and physically fit. These things are easily possible with the help of this meditation, because uh, the chakras and the system we have within us, they are nourished, they are looked after by Kundalini energy when it awakens and when it rises. Being the natural and divine power, it nourishes those chakras, and those chakras uh, nourished by Kundalini, they work properly. Their function is in proper way, and therefore they can handle all the organs of our body properly. Even the chakras also look after some certain qualities. If we meditate regularly, some qualities are also there, which are due to the chakras. We get those qualities by meditation on some certain chakras. For example, third chakra, as we have seen, is related to satisfaction. If we are satisfied, if we uh, have quality like satisfaction within us, then certainly we can enjoy everything around us and we can become a good or balanced person at personal level. Second chakra uh, helps us to overcome or balance our thoughts, and even the sixth chakra, Agya chakra, that helps us to be away from all the thoughts. We, as we have said, we have seen that either we think of the past or the future. So when we meditate, we are in the present moment, and getting present moment experiences helps us to be peaceful and to be joyous. After that, after that, uh, obviously, as there are some spiritual qualities that we get with the help of regular meditation, we understand what is good for us, what is bad for us. In that way, we can become wise in our actions. We can balance our decisions. We can take balanced decisions because we are in balance. Then there are some physical diseases like diabetes, cancer, or even asthma. They can be cured with regular meditation, because meditation supports you from within, and that is important, because whatever external applications are there, those external applications can be useful if your inner system is okay, if your inner system is working properly. Apart from that, we also have some corporate benefits at our workplace. As we are working in educational sector, many of us are busy in lot many activities simultaneously, and at that level, getting balance becomes somehow difficult. If you meditate regularly, you find proper balance of all the activities at workplace, because your activities are done properly, as your concentration is there, your confidence is there. You do not get indulged into some unnecessary activities. Your energy is not wasted unnecessarily. So certainly it results into optimized productivity. You focus on your work, and automatically, if you become a balanced person, it helps you to have positive attitude. Obviously, everybody has to face some negative situations, but in those negative situations also, we try to focus on positive things. So therefore, our attitude or our approach becomes constructive one, and therefore, as we are satisfied with everything, our practice is also ethical. We do not get involved into some unethical practices, and then we can handle the work pressure effectively, and we can also become a creative person because these chakras, they support us not only at physical level. uh, I think Ashish sir has thrown a light on this particular slide, like how our energy centers look after the different organs of our body, like first chakra Muladhara, that helps us to uh, solve problems related to prostate, womb, and excretion. Even Swadhisthana chakra looks after our liver, uterus, pancreas, and eyesight. Third chakra, Navi, which looks after the stomach part, intestines, spleen. The surrounding area of Navi chakra, that is called as void, it looks after the stomach and intestine. Even digestion part is also looked after by that. Heart chakra and Vishuddhi chakra are there. These two chakras are very important from the point of view of, uh, especially in today's situation when we are surrounded by some viruses, especially the pandemic situation we have faced. Uh, During that period, these two chakras helped us a lot. Those people who were meditating regularly, they did not get affected by COVID or different kinds of viruses because uh, Vishuddhi chakra looks after the organs like mouth, nose, teeth, tongue, face, all the ENT organs. They are looked after, they are cared, they are nourished by this chakra. Therefore, you do not get affected by those viruses. And even heart chakra is related to creation or generation of antibodies in us. Therefore, when we have proper functioning of our heart, we feel strong, we feel confident, and our antibodies work properly. They support us to fight against any kind of disease. Then on forehead, as we have forgiven everyone. So this particular chakra helps us to look after our optic thalamus, the hypothalamus part of our brain. And limbic area, as brain is the control of all our uh, being, like our physical, emotional, and mental being, that is looked after our brain. So brain helps us to overcome these issues related to our all these physical and mental beings. So this is the last chakra where we get integrated, we get connected. Apart from that, each and every chakra has some uh, scientific name, and some qualities are also there. Like first chakra, Muladhara chakra is there, which is known as pelvic plexus, which gives us qualities like innocence. Second is Swadhisthana chakra, known as aortic plexus in medical science, and its quality is creativity. We become a creative and dynamic person with the help of Swadhisthana and Navi chakra. Like Navi chakra looks, which is known as solar plexus, that gives us satisfaction. And once we are satisfied, we can have a very peaceful life. We can have a stable life. Then cardiac plexus is the fourth one that gives us confidence. That also generates some antibodies in us, and that helps us to be strong. We feel confident because we have that satisfaction within us, and we have all the you know awakening of the chakra that makes us strong. Then Vishuddhi chakra looks after the communication qualities, known as cervical plexus. Agnya chakra, known as optic chiasma, looks after the forgiveness. Most of the times we are angry with somebody, we do not have any good relation with people. So our relations with people, they improve when we forgive them. So forgiveness is the quality we get from this chakra, and we feel better when we forgive. And integration of all these qualities, all these chakras, is at the fontanel bone, which is known as the Sahasrara chakra or limbic area. So these plexuses or chakras, they give us some certain qualities like these, and they help us to become a balanced person. These qualities can be easily developed with the help of these chakras. But for that, obviously, awakening of Kundalini is necessary, and that should be situated at the top of our head. For that, we have to meditate regularly. Like as we plant a sapling, we give it water and all the nourishment, and then it grows properly. In the same way, now your sapling is planted. You have to make it grow by regular meditation, and for that, you need to keep your Kundalini awakened, keep it on the top of your head. For that, meditation is like functions like water and nutrition. So, meditation is like putting oil into the lamp that gives you light. So for that, you just have to give 10 minutes in the morning and 10 minutes in the evening, or wherever you get time in the throughout your day. Just have to sit for meditation and feel whatever now you have felt while you did meditation. If you're feeling the same thing at the time of meditation. So before we go to the next part, I request you to let us practice how to meditate at home. Now you need not to do all those 3 steps that we have done earlier. Now you can sit simply like this, wherever you are sitting. You can keep your hands open, palms open, like in your lap. And by closed eyes, you can keep your attention on the top of your head. In this position, just try to, shall we do this? Shall we practice this? Is there time left for 10 to 15 minutes more? 5 minutes will go for this. After that, uh, so that you can practice it at home also. You can learn how to meditate at home. So the method that now you need not to do all these 3 steps. You just sit like this, as this person is shown in blue color. All right. So slowly let us close our eyes. I request all the participants to give next 2 to 3 minutes for practical part of meditation. Now I request to keep your eyes closed. Put your attention on the top of head, both the hands on our lap, palms facing upward. We'll just pray our Kundalini, which is like motherly power to us. We can say Mother Kundalini, or we can say, Oh God, say Shri Mataji, any name that you wish, you can take. Oh Mother, please awaken my Kundalini and let me feel it on the top of our head. Just close your eyes for 2 minutes. When you pray by heart, just check on the top of your head as well as both the palms, fingertips, whatever you feel. It must be like, some cool breeze, some warm feeling on both the palms and top of your head. Just try to feel peace within us, calmness that we have. Even there are thoughts, we neglect them. We don't pay attention to them. Slowly, we become thoughtless. Now, just do one thing. Get your right hand above your head and check. You can feel some cool breeze coming out of your head. You can feel cool breeze at the top of your head. You can take your hand a bit above, up and down, slowly. Take cool breeze coming out of your head, coming out of the top of your head. Move your hand up a bit above or downwards. Check. If you're feeling it, take your right hand in your lap. Now check on both the hands and top of your head, whatever you're feeling. Now slowly just lift your left hand on the top of your head and check whatever you felt on the right hand, whether you're feeling the same to your left hand also. Take your left hand a bit above and will slowly up and down on the top of your head and check if some energy is there that you can feel in the form of cool or warm breeze. If you're feeling it, then now keep both the hands in your lap and hold attention at the top of head and both the palms. Now slowly you can open your eyes. I hope at this time everybody might have felt something on both the hands and top of head. This is what is the experience of meditation. You can sit in this position for 10 to 15 minutes in the morning and in the evening or wherever you get time throughout the day. So this is how meditation is very easy. You can do at home regularly, and whatever benefits we have talked about, you can check on your own that if you're getting those benefits or not. Because this is a part of experience. You will learn it step by step. No matter even if you haven't understood everything that we have shared with you, but the most important thing is you must be able to feel the energy within you that helps you, that guides you for your regular meditation. So this must be the way of meditation at home. We need not to do anything else. We just have to add this part of meditation into our daily practice, as we have some certain daily schedule. Like we go for a walk, we have some exercise, we listen to music. In the same way, you can add 10 minutes of meditation early in the morning and in the evening, whenever you get time. So I think we have talked about this. That left side, if we use our left side, we become weak person, we become emotional person, and if we use our right side, like if we go for too much planning, if we have work, if we become workaholic, unnecessary focus on work, if we become aggressive and anger, we use our right side, and nobody likes the person who is either right side or either left side. We even don't like people, or even we ourselves don't like to be depressed, lonely people, or more over emotional people, and even not neither aggressive and angry or dominating. Rather, everybody wants to be a positive person with peaceful approach and obviously having emotional stability away from all the stresses and burdens. This complete balance helps us to have enjoy our life in the real sense of meaning. And everybody appreciates like this. And even I hope I'm audible.
Yes, sir. Now you're audible.
Sorry, there is some technical issue. I just wanted to tell all the participants that this is the right time, exact time where you can start your meditation, because the later time never comes, and certainly you cannot escape from saying that I'll do it later or I don't have time. As we have seen, we have enjoyed the moment of meditation only in 10 minutes, and in 10 minutes, or rather 5 minutes, we might have felt peaceful, we might have felt free of thoughts. And certainly there are some certain myths in the mind of people, that people feel that I cannot enjoy my life if I start meditation. People who meditate, they are really very serious people. Actually, this is not the case. Those people who meditate regularly, they have their families, they go to picnics, they enjoy their routine work. Rather, everything becomes joyous for you when you incorporate meditation in your daily life. And therefore, you do not become Baba or any kind of person. Rather, you become a person who enjoys his or her life in the real sense of meaning. You need not to change your routine habits. You need not to change your, way of worshipping. Yeah, even you need not to go for some other things like, my eating habits needs to be changed. Nothing like that happens to you. You have to continue your routine work, your routine lifestyle. You just have to add this part of, meditation into your lifestyle. That is the only thing we have to go for. So these, things are there. They obstruct us from getting into meditation or practice meditation regularly. And apart from that, there are some helplines that you can get while meditating regularly. I'll put those things in the chat box. Meanwhile, if you have any doubts, if you want to share any experiences of meditation, you're welcome. The forum is yours. We still have, I think, 10 to 15 minutes. So within 10 to 15 minutes, I'll try to, will try to satisfy your doubts or your questions. So thank you very much for your patient listening. I'll share one slide with the coordinator, Dr. Khosla ma'am, and she will share those details with you. There is a link for feedback. If you want to learn more, you can feel that feedback and you can get more information about it. So there is a toll-free number. If you can note it down, like 1800 2700 and 800. This toll-free number is there. If you need more information about it, you can get it on this number. Then there are some YouTube channels also, which are freely available. You need not to pay any fees for that. All over the world, all these programs of meditation, they are free of cost. We don't charge anything for any program, and there are no levels. No, I posted the toll-free number in the chat box. There are no levels, no classes that you have to join. You just have to meditate regular, early in the morning and in the evening, or whenever you get time throughout the day. So I have posted the number in toll-free number in the chat box. Even YouTube channel is there. Learning Sahajayoga is the name of the YouTube channel, which you can find for regular practice. There are some websites also which you can refer to. Mainly one website is there, sahajayoga.org.in. I have posted it in the chat box. There is one more website, freemeditation.com, which can also be referred to for more information, where you will get a lot of information freely. So these things are readily available to all of you. You can join it, you can practice it, and then you can enjoy your life at corporate as well as personal level, even at family and social level also. So in that way, we become dynamic person. This is all from our side. We would like to again request you to practice this at least twice a day for a couple of weeks, and then you can see the changes. Because to learn something new, it takes some time, at least 1 or 2 weeks regular, and then you will master it on your own, because the energy is with you. and you can get benefits of it. So if some participants can share their experiences, or if you have anything to be asked, please feel free. Thank you. Thanks a lot.
Any queries from the participant side or any point they want to discuss?
Yeah, I will be happy to know your experiences.
Yes, sir. Sir, do you have any meditation center in Faridabad?
Yes, there are some meditation centers, but due to, I think, this pandemic situation, some of the meditation centers may not be functioning right now, but you can join that YouTube channel. You just fill the Google form that I'm going to share with you, so that I'll be able to share the details of Faridabad Center to you.
Okay,
I'll
thanks.
share the link.
Thank you, sir.
Yes, thank you. So, and how did you feel when you meditated?
What,
was
sir?
how did you feel when we meditated? What was your experience, sir?
Sir, I have no experience of meditation.
Okay, good. What was today's experience?
Yeah, today it was fine, sir. Feeling more calm.
Okay. Yeah, thank you for sharing, because it's really a wonderful experience. We feel calm and peaceful. I posted the link for feedback in the chat box, which you can fill, and if you give your details there, it will help you further free of cost. There are no charges for that. All over the world, this centers are free.
Thank you very much, sir, for this wonderful session. The session was actually the medicine of the life, so that we all should take. This is the only medicine I must say that we should follow. Thank you very much, sir, for the wonderful, fabulous meditation that we have done, and we wish that all the participants they will follow these practices in the near future.
Yes, thank you all the participants, and even to you also for providing this opportunity.
Thank you, sir.
I have posted the link in the chat box. If some participants want to get more information about it, they can fill up the form and let us know, so that we can help them.
Yes,
And
sir.
again, I request all the participants to try this at home today itself, and even tomorrow morning, and regularly morning and evening, 10 minutes at least, for a couple of weeks, so that you can learn it and you can get the benefits. Thank you. Thanks a lot.
Sure, sir. We will follow these things in our daily life. Thank you very much, sir. And thank you all the participants for the session. And in 10 minutes, by 3:30, we'll be starting the next session. Thank you all of the participants. You can stay tuned to this meeting. We will be starting by 3:30.
Yes, good afternoon, everyone. Am I audible?
Yes, ma'am, you are audible.
Yes, ma'am. Good afternoon, ma'am, and good afternoon to all the participants. Now the next session is of Dr. Asha Rani. Asha Rani has received her BTech in Electrical Engineering from Regional College in Hamirpur, Himachal Pradesh in 1998. She received ME degree in the Electrical Engineering from IIT Roorkee in the year 2000 and PhD in 2013 from the University of Delhi. She has joined as a lecturer in Instrumentation and Control Engineering Division at Netaji Subhash University of Technology, New Delhi, and currently working as a professor in the organization. She has published many papers in the international journals and conferences and guided more than 28 MTech and 6 PhD scholars. Three PhD scholars are still working under her. Her areas of research are renewable energy, intelligent control, adaptive control, soft computing, based adaptive control, biomedical signal processing, and robotic manipulators. So today she will be discussing about modeling and control of robotic manipulators. So I welcome you, ma'am. On the behalf of Manav Prashna, I welcome you and I request you to kindly take over the session.
Okay, thank you, madam. And I feel obliged for calling me for this session. And I hope that this session will be helpful to all of us, sharing my experiences. And if there are any queries, I'll try to solve them out. So let me first present my screen.
You can present by from share screen option. You can present.
Yes. Yeah, I think I'll require to quit and reopen because it needed access. Let me see whether it's done or not.
Ma'am, please try now.
Okay.
Yes, ma'am. Your screen is visible now.
It's visible?
Yes, ma'am.
Okay, thank you. So my presentation is also visible?
Yes, ma'am. It's visible, ma'am.
Okay, so you the screen is okay, or you want me to remove the sidebar?
No, ma'am, it's okay.
It's okay, no?
Yeah.
Okay. So good afternoon, everyone. My topic is on modeling and control of robotic manipulators. And modeling, we know most of the systems can be modeled using differential equations. So here also we have a set of equations, and using those equations we can model any manipulator. And when we want to do control, because we know that most of the robots or many robots are used in very, you can say, precise applications. Suppose in robotic surgery, where you want the movement to be highly controlled and highly precise. So in that case, we need, you can say, a robust sort of control. And for that, the tools which we have used here are the soft computing tools. So again, means first we will be modeling them. First, I'll be actually telling you about the basic introduction of the robotic manipulators, then how do we model them, and then some research sort of thing which we have done to control the robotic manipulators. So this lecture will be covering the introduction to the robotic manipulators. And here actually when we talk about manipulator, it's actually a robotic manipulator, because you have seen a variety of robots, and manipulator is a sort of, you can think, which can pick and place sort of work can be done, or some task, painting, welding, those types of tasks, which or I can relate it to my hand. Suppose my arm, the movement of the movement of my arm, and work done by my hand, and the movement of arm is supported by the movement of my shoulder also, movement of the waist joint also. So all those things means which I can do by hand, I want to do that with the help of the robotic manipulator. And this is also called as the, means it's a manipulator is nothing but it's a robotic arm with the rest also, as we are having a arm and a hand. So similarly we will be having a manipulator which is doing a work similar to the work which humans can do with their arm or their hands. So we'll be discussing these robotic manipulators. We'll be, and we are having two types of manipulators. One is the serial robotic manipulator, then we have the parallel robotic manipulator. Then, as I told you, that why do we need control, or what type of control is required, so motivation behind the work. Then the different control strategies which we can do for which we can use, or which are generally available in literature, and which are already designed by students. Actually this work is done by my students. Then because whenever we talk about the controllers or controller design, there are certain parameters which are, say, tuned. We need to fix them according to the requirement of the application. So that tuning part, or you can say, is done with the help of the optimization techniques. So we need to have an optimized, you can say, objective function, and whichever parameters give us optimized objective function, those parameters are chosen. So accordingly, uh, is there any issue in my presentation? You can hear me? My screen is also okay? Everything is going fine, or is there any issue?
Yes,
Can you
madam.
hear me?
Yeah, we can hear you.
Okay. Okay, so then we'll be talking about the results which we have achieved using the different control strategies which we have done, and finally the. Okay, so first of all, we'll talk about the robots. So when it's a robot, means you are doing it with the help of a software controllable mechanical device, and it also requires, it also has sensors which can detect movement of the
Ma'am, please, please unmute yourself, ma'am, please.
Okay, it's
Yes, ma'am.
done now.
Yeah.
Yeah. So it means it's a programmable mechanical device. It's a multifunctional manipulator, and it can move materials, it can move parts, tools, or some specialized tasks can also be done, some programmed motion. Just a second, I got a call from VC office, so just give me a second.
Single page पे बनाना है। ये सारे ये सिंगल एक पेज पे एक है, ठीक है, वो आगे पीछे
सारे पेज एक साथ मोड़ दो, सारे मोड़ कर सकते हैं,
फिर वो उसको कभी समझ में
आ जाता है।
एक और लेकर
शांत कर कहता है, उससे पूछना तेरे से कि आपने आपसे ना मेडिटेशन करवाई थी, इससे क्वेश्चन पूछते हैं कि आपने आज मेडिटेशन की आपको कैसा एक्सपीरियंस हुआ? इससे कुछ और अगला पिछला तो लेक्चर सुना नहीं था। मेडिटेशन
Sorry for the interruption. Actually, I got a call from PC office, so I could not help it. So we have a robot, and it's a programmable device, and we want to do programmed motions are done to perform a variety of tasks. And we all know that robots are used in various engineering fields, and we require improved accuracy and precision. And for effective manipulation of manipulator, you require the tight position control. A highly efficient position, robust position control is required. So what are the different characteristics of the robot? It should show repeatability once you're giving some command, and it's performing some movement, and another time when you give the same command, it should be able to repeat that. Then we should be able to do manual as well as automatic control. And the speed of operation is also defined, which speed we need. Sometimes we might require a very quick operation, sometimes we might require slow operation. So speed of operation is also a characteristic of a robot. Then, as I told you, that robots are a variety of robots existing in the world, but in this lecture or in this work, today's work, I'm focusing only on the human arm. So manipulator mimics the human arm. So when we say human arm, means robotic arm will be modeled as a chain of rigid links, means you will be having some links, and these links will be connected to each other. Suppose I have two plates, I make hole on those plates and then superimpose those holes and put a pin on this hole, then I will be able to move one link like this. So this is how we allow the movement, and this is how our joints even work. Our shoulder joint work, or our elbow joint, it also works in the same phenomena. So we have some rigid links, rigid manipulators. We also have some flexible manipulators where this link may not be rigid, it may be flexible, but in today's topic we are not talking about that. So right now we are talking about chain of rigid links. You may have a chain of links, they're connected by flexible joints. And when we are mimicking a human arm, means our links correspond to our chest. It can upper arm, then we have a forearm. When we talk about joints, then we have a shoulder joint, elbow joint, and multiple joints in the wrist. And at the end of the arm, there is an end effector, or a tool, or a gripper, or a hand. Now when I want to do welding, then it will be some different types of end effector. When I want to do pick and place, then it will be some sort of gripper, depending upon the requirement. Suppose we want to do some hammering, then accordingly a tool will be there. Then tool, sometimes this tool will have two or more fingers that open and close like a tongue, and or as our fingers open and close, grip an object and then drop it on the another place. Now when we talk about a robotic system, complete robotics, okay, let me tell you this one. This is an example or a figure which represents the robotic manipulator. So here we can see this one is our base, which is not moving, fixed base. Then here we have some sort of thing like this, and to this portion we have attached this another link, you can say, and both of them are attached to each other, and this can move in this direction. So it's behaving like a shoulder joint. Then similar joint is available here, and link between joint between this portion and this portion, and it can move up and down. So another joint may be like elbow joint. Then we may have a link like this, suppose forearm, and then we have a wrist sort of thing where you will have rotary movements. Now these movements, suppose I talk about this movement which is about shoulder joint, first one, then about elbow joint, second movement. So these movements are allowing to place our wrist in the space, means by doing this movement I can make my tool or this end effector to be placed here or to be placed here or to be placed here. Means the work of the arm is to place the wrist. And then because when you have to pick anything, suppose on your table, then you will move your shoulder, you will move your elbow, move your waist, and accordingly you will try to reach your hand near the object. And then when you want to pick an object, then accordingly you have to give, you can say, motions in the wrist joints. In particular, actually in the wrist also we have 3 joints or 3 types of rotational movements when we do it mechanically. So in the 3-dimensional space, the 3 rotational movements are represented using the are you can say are formed in the wrist. So 3 rotational movements are formed, and this wrist will orient our fingers such that we can pick an object. Suppose you want to pick a glass, then it will be picked up differently. Suppose you want to pick a ball placed on the table, then you have to go vertically. Agar aap, if you're picking a glass, then you will go horizontally. Accordingly, means the orientation of the hand has to be done, and this orientation part is done by doing the movements of the wrist. So wrist orients our fingers in the direction of the way we want to pick, and the movement of these joints, the arm joints, they help to place the wrist or to make the wrist to reach a certain position which we want. Now to do this whole, we have a complete robotic system. What are the different components of the robotic system? We have a manipulator, which we discussed right now. This one is a manipulator. So robotic system will have this manipulator. Then it will have a pedestal, because this base which does not move may be called as pedestal, or sometimes it may move on a train or something like that. So it supports the manipulator and it acts as a counterbalance. So that pedestal sort of thing or base sort of thing of the manipulator needs to be quite heavy. Otherwise, when suppose it is picking up some object here, and if that object is very, very heavy, then it may fall down. So you need this base to be very heavy so that when it is picking up some object, it does not fall down. So that's an important work of the pedestal or the base. It supports the manipulator and acts as the counterbalance. And you also want to give a programmed motion to the different joints, because these joints need to be connected with the help of connected to the motors. So when motor is rotating, the rotation will be passed on to this. Suppose you connect a stepper motor, and the stepper motor moves in a particular angle, suppose 30-degree, and 30-degree movement is suppose passed on to these joints. So these joints will be actuated with the help of the motors. Now these motors will be given command that how much degree we want to make our joint move. So that command will be given through some peripheral devices, and this is called as the controller, you can say, or the brain, which issues instructions to the robot through these motors. So some current or some sort of a sequence or some pulses are given to the motors accordingly, in which direction we want to make it move. So instructions to the robot are given, then peripheral devices need to be controlled. In the interfacing, all part to be done with the help of the controller, and interfacing with the human being also. When we talk about the peripheral devices, there may be sensors also, and interfacing between the hardware and the software. So whatever signal you're getting from the sensor, you have to give it to the system, and then it is evaluated, and accordingly the signal is to be provided to the motors, and then the robotic manipulator will move in a certain direction. So this is the complete work is done with the help of the controller. The controller may be on a small chip, even suppose like a microprocessor sort of thing, or a microcontroller, or it may also be a PC. So you may have a controller here. Then the end effectors means what work we want to do. If we want to do a pick and place, then it will be simply a gripper with, you can say, 2 or 3 fingers like our hand. Or if you want to do welding, you want to do spray painting, so accordingly the end effectors will change. So the main application will decide which end effector we want to use. And now everything works with the power. So the power source is also a part of integral part of our robotic system. So it's just an example like this. Suppose we have a controller sort of thing here, the brain part, you may have a power supply, and this is connected to your robotic manipulator. This portion from here to here is the manipulator, and this manipulator moves on this rail, इस पे move करता है, and it can work. This whole is your, this portion is the workspace where it works. So this complete system forms the robotic system. Then we all know we have different types of robots. We have mobile robots which move around the environment. Physically they move. Sometimes robot moves physically on the floor. Sometimes it is only placed on a table and it will work. So you may have a mobile robot, you may have industrial robot which are used for welding, material handling, painting sort of thing. Then you may have a domestic or household robot, suppose cleaning, pool cleaner, like that. Then you may have medical robots which are used in surgery, in medical institutions. Then we have military robots where these robots are used when in I can say dangerous places, and it may also be in the form of drones, and transportation robots are also there, bomb disposal robots. So different types of robots are present. Then if I what is inside the robot, we will be having mechanical components like links and the joints, and we have, as I told you, motors will be actuating, means motors will be driving our joints. So the drivers are like servo motor or stepper motor. The drivers may be even hydraulic or pneumatic cylinders. So actuation of the joints or the movement of the joints is done with the help of the actuators. Then you need to do the power transmission, because when a motor moves, the exact torque which a motor produced may not be required by the robot. So you have to sometimes step down or step up the speed or the torque. So accordingly that can be done. So power transmission and stepping up and stepping down can be done with the help of the gears. You can use chains, you can use belts. So those mechanical devices again. Then the many types of sensors are used. Few are written here: LVDT, you may have camera, you may have force or torque transducers. Then the controller which we require may be a microprocessor, it may be with memory, or you may have computers. So these all are, can say, components of the robotic system. Now how to, means the basic thing when we want to do some research in the robots, you cannot simply pick a big humanoid robot and then start doing something on that, because we all know that when we want to experiment any new technology, to test any new control strategy on any system, you need to model it. So means mathematical equations are written, and then you simulate those equations using some platform, say MATLAB or Python, or other ROS, robot operating software is also there. So different types of softwares available by which you can model those robotic manipulators, and accordingly you can analyze the different inputs and the different outputs, and you can also analyze how the controller is behaving. So that is a preliminary sort of thing before putting that control strategy into the actual application. So for that, when I want to do modeling, then I should first know the anatomy of the robot. So as I told you, we have a base, we have different arm, we have arm, and in the arm we have different links. So you have suppose this is link 1, this is another link. You may have a wrist here, and finally the end effector here. End effector is shown as a 2-finger sort of thing, and it may pick and place an object. Now as I was talking about the orientation, suppose my object is lying here and it has suppose approached here, but I want this robotic manipulator to pick it from above. So then it has to be oriented. So means this tongue sort of thing needs to be rotated downward, so that finally it grips the object and it will be picked up. So that part is actually done with the help of the, means positioning of the end effector is done with the help of these links and the joints, and orientation of this gripper to pick up an object. Now suppose my object is here, the fingers gets rotated, it cannot pick up. So that orientation part is done with the help of the wrist. Then I'm connected now.
Yes,
Then,
ma'am, connected.
yeah, actually it was showing that my connection is
No,
unstable.
no, no, ma'am, you are connected, ma'am. You are on
Okay.
modeling of robotic
Yeah,
manipulator.
thank you. So
Yeah.
when we want to do modeling, then modeling requires all these things, because we should know the anatomy, then we have to do the kinematics, then we also need to specify what velocity and acceleration should be of the different joints or of the end effector, and then what are the forces acting internal or external on the robot, and using all these things finally we will be able to reach the dynamic model of the robotic manipulator. Now when we say kinematics, it's just the spatial representation of the, you can say, position and orientation of the end effector. Means if I suppose I say that if this is my position of one joint, suppose if this, by this angle my first joint has moved, suppose theta 1, and suppose this is the angle by which my second joint has moved, and suppose I also specify the angles of the rotation of the wrist, and finally using these theta 1, theta 2 and the parameters of the wrist, I will be able to tell that what is the position and orientation of my end effector. So just by looking at the spatial, you can say, representation in 3D space, it is modeled, or this sort of, you can say, relationship is represented using the kinematics. And this kinematics is nothing but it's just a transformation matrix, where we say what actually we do, we attach different frames to the different links, and suppose I have a base frame like this which is not moving, then I have a frame suppose attached with my first joint, first link, then I will have a frame attached with my second link, then I'll have a frame, last frame, which is attached with the end effector. And then we study, because what happens right now, when you can see that this frame is aligned with this frame, means this axis is aligned with this axis gets aligned with this axis, this one is aligned with this axis. So both these frame 2 and frame 1, both of them are aligned with each other. But what happens when suppose a movement takes place and we say that these frames are actually, these are virtual, they are not real. So this is a 3D frame, 3D space, when the, and it is rigidly attached to the link. Now when link rotates, suppose link rotate karega to kya hoga, this axis suppose moves to this position, this axis moves to this position, and this axis moves to this position. So the rigidly, initially actually the frames are attached to the home position, zero position or reference position, and when it starts rotating, the frames also rotate with the link. And then finally we study the relationship between the position and orientation of this frame with respect to the base frame which is not moving. So that representation or that relationship is represented using the transformation matrix. So transformation matrix is a relationship between the different frames, or I can say relationship of the end effector frame with the base frame, which help us to know what is the position of the end effector right now, and what will be the input to that model. Input will be the different angles of the different joints. Okay. So similarly, I can also do inverse kinematics, means if I know the, if I want my end effector to reach this workpiece, then what should be my angle theta 1, angle theta 2, orientation of the wrist, if I want to do that, means I know the position of the end effector and I want to know what should be the joint movement so that I can reach this position, then that can be done using the inverse kinematics, and there we go for the inverse of the transformation matrix. So that is also part, again a spatial relationship. Next is sometimes we also require that our robotic manipulator end effector should move with this much velocity, this much acceleration. And suppose I know the joint velocities and I want to know what is the velocity of my end effector, then that relationship is obtained using the Jacobian matrix. Means I am given with the velocity of the different joints and I want to know what is the velocity of my end effector. Means I know velocity here, suppose v1 omega 1. I know the velocity of the second link, that is v2 omega 2, linear velocity, angular velocity. What should be the velocity of my end effector? Then that can be done using the Jacobian matrix. I know these and I can find out this. Or you can also do in reverse. I want that my end effector should move with this much velocity, this much angular velocity. What should be the velocities of the joints? That can be done using the inverse kinematics, inverse Jacobian matrix. So you can see that again, when we talk about the velocity or acceleration, right now we are not dealing with the forces. We are only dealing with the rate of change of movement. Now, what are the different forces acting on the different joints, different links? Now, the forces which are acting here on the link will depend upon what is the velocity, the linear velocity, what is the angular velocity, what is the weight of the arm, what is the inertia of this particular link. So accordingly, and again, how much force or torque our environment is exerting on the end effector, means whether I'm picking a heavy object or I'm picking a light object, accordingly the force will come on the whole robotic manipulator. Now our purpose is that there should be these forces which are developed, internal forces due to inertia, due to centrifugal force, or due to acceleration due to gravity, or force which are coming external from the environment. All these forces need to be balanced by the force or torque which is supplied to the joint. अब सपोज आपने कुछ पिक किया है और वो इतना हैवी है कि आपके ये आर्म को नीचे शिफ्ट करने लग रहा है, तो क्या करना होगा? वी हैव टू मूव दीज जॉइंट्स, वी हैव टू प्रोवाइड मोर टॉर्क टू दीज जॉइंट्स सो दैट द ऑब्जेक्ट कैन बी picked up. So all those force calculations are also done, and then finally we do the robot dynamics, where we write down the equations of motion. Means I want to know what should be the torque or force applied at a joint, and how this force or torque applied is used in my robotic manipulator. So the force and torque need to be balanced. So this is an, you can say, input torque or input force, and here is how it is being used in the system. जैसे कि आपने voltage देते हो तो आपके resistor में कितनी use हो रही है, inductor में कितनी use हो रही है, accordingly. And similarly here, when you are providing torque, how much torque is being used to balance the inertial force, how much torque is being used to balance the, you can say, velocity or acceleration or centrifugal forces or acceleration due to gravity. So all that balance needs to be done, and this finally leads to the dynamic model. Now once I have obtained this dynamic model, now I can simulate, means I can provide a trajectory. Suppose I want my robotic end effector to follow certain path, means I want this to move, suppose like this position. ये हम चाहते कि इतना ज़्यादा घुमा दिया हमने. So let's suppose I want my manipulator to come to this position. So this is my trajectory for this particular sort of task. So I'll specify, I'll give this program, I'll give this command to the controller that this is my, because current position is known, but I am giving the robotic manipulator that I want my end effector to reach this position. So accordingly, by means using these equations of motion, I'll be able to know that how much torque must be supplied to the different motors here, and how much rotation needs to be done in the wrist, and accordingly I'll be able to follow this path. The end effector will move along this path. So trajectory I will define, and then the robotic manipulator will follow this trajectory. And how will it follow? By supplying a torque which is allowing my end effector to move in this path. So accordingly, or I can also say this trajectory, when I am saying this trajectory for the end effector, how my theta 1 is varying along this path, how my theta 2 is varying along this path, that also can be calculated. And finally, that when I want to follow these theta 1 and theta 2, then what are the torque required at the different instants of time, that will be, the torque will be calculated and will be supplied to the actuators, and finally robot will move along this path. And what is our work? Our focus is to follow this path rigidly, means there should be no error between the actual path and the desired path. So we want the proper path tracking, precise path tracking. Now here this was the introduction how the robotic manipulators are, can say, modeled. Now coming to the different types of manipulators which I'll be discussing here. One is the so when I have a robotic manipulator, when it is of this form, then it is called as the serial manipulator. But sometimes you may have a parallel link also, एक और एक loop बन गया है, then in that case those types of manipulators are called as the parallel robotic manipulator. So the one which we are showing here is again similar to, it's a two, you can say, if I'm not having this wrist, then it is a two link manipulator. Okay, so here in this work I'll be discussing two link rigid manipulator. Again, it's a planar manipulator. Planar means it is only sweeping a plane. Suppose if my manipulator is like this, then it cannot go above the screen or it cannot go behind the screen. It will be able to pick and place object only which are lying on this screen or suppose a table. So this is a two link. So we'll be discussing two link rigid manipulator. Then we'll be discussing the parallel robotic manipulator also. One more, you can say, very common manipulator is Maryland manipulator. It was designed by Maryland University and it was named after that. So here the motivation behind this is that these robotic manipulators you have seen, they have very highly complex, they are highly complex and multi-input, multi-output systems. They have non-linear and vague dynamics. And we require, because as I told you that these robotics manipulators may be put up in certain applications which are very, very, you can say, crucial, and you require accurate and tight position tracking of the end effector, and it becomes a challenging task. Means you have a complex system, you have a MIMO, it's a non-linear, dynamics are also vague, and you require accurate and tight position tracking. So it becomes a challenging task, and therefore the task is being, you can say, you can say the solution is that we can go for computational techniques, soft computing techniques, to design controller for such, you can say, complex systems. And there are disturbances also in the system because you are using motors, and the motors suffer from cogging and eccentricity, and it may affect the tracking performance, and therefore the disturbance also needs to be avoided, disturbance needs to be rejected. Then we also want the movement of the robotic manipulator to be stable. So and we want an accurate trajectory, and therefore we are going for soft computing techniques or intelligent control strategies for tracking the robotic manipulator. So this one is the two-link rigid manipulator. Actually, here the modeling is done by considering the length of the first link, as this length is L1, the length of this link is L2, the angle with which first link is moving at a particular instant is suppose theta 1, and another angle is measured when you extend this one, and then you measure the movement of the second angle, which is theta 2. So it's a two-link rigid manipulator. Here it does not have any wrist, and it has 2 degrees of freedom. विजेंद्र सर को बोल दो. Okay, so when I want to do mathematical modeling for this such a simple robotic manipulator which is not having any wrist, it's just a planar manipulator, only 2 movements are there, 2 degrees of freedom manipulator, very simple manipulator, and it is only sweeping a plane. And if I want to write down its mathematical model, actually for mathematical modeling also we have different ways. So it can be Euler-Lagrange dynamics you can use, or Newtonian dynamics can be used to obtain the model. And as I told you that because you are having 2 joints, so 2 joints to be moved, if they are powered by 2 torques from 2 motors, then the torque of motor 1 is being used in the mass, in inertia sort of thing. Then again this one, all 3, these are for the inertia. Here it is for the velocity square, here again velocity. So it means these forces are corresponding to one is centrifugal force, and another one is also called as Coriolis force. So I think this one is, first one is centrifugal force and another is Coriolis force. So this one is due to acceleration due to gravity, and the different components are there in the mathematical model. And when I say theta 1 double dot, it means it's acceleration, theta 1 dot, it's the velocity of that angular velocity of our link 1, suppose. Similarly, we have the torque variation of the second joint, where which is also balanced by, means this torque is being used in the different forces. So this is how the mathematical model is achieved. It's a rigorous exercise, and the model is very simple. The system which we have considered is very simple, but the model is not that simple, and it is highly nonlinear. So but this is the model which we considered, and the different parameters for the two-link robotic manipulator which are considered for experimentation purpose are given here. The parameters are shown. The torque 1 and torque 1 need to be evaluated. It is in the Newton per meter, and theta 1, theta 2 are also the trajectory, because we will specify a trajectory, and how the torque is varying or how theta is varying, that we will plot finally. Then coming to the Maryland manipulator, which is a parallel manipulator, it's actually a 3 degree of freedom parallel manipulator. And what actually happens, we have a one base like this, which is fixed base, and this is another base, which is a movable base. And how it is controlled? It is controlled by movement of the joints which are present here. So 3, एक ये है, this is on, and this is another third. So the three corners of this moving platform, the position and orientation of these corners is changed using the joints which are formed here, and it's a parallel sort of thing. It's not a single, you can say, series of links or manipulators. It's a parallel manipulator, and we need to maintain the, you can say, we need to control the movement of this movable platform. And this one is the description of the joint angles, which is again quite complicated. As I told you, 3 degrees of freedom, so you will have but 3 degrees of freedom on the 3 links. So this one is for theta 1i, theta 2i, theta 3i accordingly. So if you go into this one is a bit complicated sort of model, and here you can see even the equations are not very simple. The mathematical model of the system is given like this for the Maryland manipulator. And these are the parameters which we have taken from the literature for this Maryland manipulator. And these two manipulators are used for testing different control strategies. So we have tested the, I can say, conventional control strategies, and some new control strategies are also designed. So here you have a PID controller, fractional order PID controller. We have 2 degrees of freedom PID controller, and apart from that, the other controllers which were designed are non-linear fractional order fuzzy PD plus fuzzy I, fuzzy PD plus fuzzy I, and it's a non-linear controller. Again, second one is also non-linear. It's a 2 degrees of freedom fractional order fuzzy PD, and then it was a Lyapunov based fuzzy controller, linguistic Lyapunov fuzzy controller. Now I think this one is for Maryland manipulator, and we'll see it. So if you see a PID controller, the most simple controller, where we obtain the error between the output, actual output and the target output, and that error is being used to evaluate the input to the plant, controlled input to the plant. I means if my suppose it's a positive response system, and suppose my error is positive, then my input to the means if my error is positive, I suppose I'm increasing voltage of my motor. If my error is negative, I'll reduce the voltage of my motor accordingly. Means so depending upon the error, proportional or integral of error or derivative of the error, 3 different components, each are having its own characteristic, and they can be there. This is the most conventional, most simple, you can say, controller used in many of the systems, and in industry also. The most basic controller is PID controller, but where the applications are very very important, very very crucial, there we need to have you can say intelligent controller, and it may be an intelligent PID controller. Or what we do is we enhance the capabilities of the PID controller by making it, you can say, a more complex, introducing something into the PID controller, or making it hybrid PID controller accordingly, and then we can enhance the capability of PID controller, and the performance of the system may be improved. So if you want to control a high order, non-linear, time delayed, complex and uncertain system, then it cannot be done with the help of a PID controller. It needs a intelligent controller, or it needs a, you can say, more enhanced version of the controller. And one enhancement which we can do in the PID controller is the fractional order. Now what do you mean by fractional order? Fractional order means, here you can see, when we were talking about the PID controller, the integral part and the derivative part of the controller, they are, I'll say ki they are raised to the power 1, integral power, है ना? But when we say fractional order, then the integral 1 by s is raised to the power lambda, where lambda lies between 0 to 1. Similarly, the derivative s raised to the power mu, and where mu also lies between 0 to 1. So fractional order, fraction of a 1 is used, and the order of the integral control action and the derivative control action is not integer, it is a fractional. It lies between 0 and 1. It's greater than 0 and it's less than 1. So by doing this, here you can see, when I'm suppose I'm moving a dial है ना? You have a regulator in your home. Suppose अभी पहले तो बड़े बड़े आते थे, now we are having very small, but still you can see when you move your fan regulator, then you can move from one position to another. Only four, you can say 4 or 3 positions are available in which you can move that. It's actually a potentiometer, so you can move that potentiometer in the 4 positions. But suppose if you can move that in a very fine manner, means apart, instead of moving that regulator to only these 4 positions, if you are able to move it in between, means if you can do the fine movement, it means it has to be done in fractions. So similarly here, when it's an integral part control action, it's complete integral control action. But now what I want to do, I want to reduce, I don't want to use the complete integral, means I want to do the fine tuning. I want to increase the flexibility. So similarly here, the derivative part is not given as such, the complete derivative. I can tune it, I can fine tune it, I get a flexibility, and I can manage my U by varying the lambda and U, and this lambda and U also need to be tuned, because when you do a PID controller, how do you do? You, when I want to use my PID controller in a certain system, servo motor hai, koi bhi aapne lagaya, and now you want to operate that using the controller, PID controller. Then, for suppose if it's an oven system, then your KP, KI, KD will be different. If suppose it's a servo motor, then your KPKI, KD should be different. If it's a oven control system, because I'm taking oven control system because it's a very simple and it's used in many UG courses in almost all labs of control system. So if it's a very small, then your KPKI, KD will be different. If it's a different order system, a larger system, then your values will be different. Means you need to tune these parameters so as to obtain an effective control. Now, when I say it's a fractional order control, then apart from these parameters Kp, Ki, Kd, I need to tune the lambda and mu also. So these optimal values, because the controller will not give a good, you can say, performance if I'm not selecting my these 5 parameters appropriately. So my controller will only work properly if it is properly tuned. Otherwise, it will not be a good controller. Okay? So, but I am interested in a highly efficient controller, and that can be done only by optimizing these parameters. So that is why the optimization come into picture. Then we have a 2 degree of freedom PID controller. Means one enhancement which we did in the PID controller was introducing the fractional order to the integral and derivative control action. Another enhancement which we can do to PID controller is to introduce 2 degrees of freedom. Means the normal PID controller which we were discussing right now is called as 1 DOF, 1 degree of freedom. Now here we have 2 degrees of freedom, and by doing this you can see here we have a P here. Then generally when you used to have only 1 DOF, you used to have this P feedback as, suppose let it be unity, and then you used to have a controller transfer function, and finally it becomes a complete closed loop system. But when it is 2 degrees of freedom, then this extra branch is introduced and it forms one more loop, and it gives us it increases the degree of freedom, and it is called as the 2 degree of freedom PID controller. Now by doing the block diagram analysis, finally you can find out that what should be your C dash and what is your CB, and the overall control action will be depending upon C dash and CB, and these depend upon, means these are modeled using these 2 mathematical expressions. Now in these mathematical expressions you can see we have 2 parameters apart from Kp, Ti, 1 upon Ti is Ki, so I can write Ki or I can write 1 upon Ti. Then we have Td, similar to Kd. So we have Kp, Ti, Td, 3 parameters of PID controller. And apart from these 3 parameters of PID controller, we have alpha and we have beta. So when I do 2 degrees of freedom, then I am introducing 2 more parameters into the controller. And when I am using fractional order PID controller, then also we are introducing 2 parameters into the PID controller which need to be tuned. Now when I am tuning only one parameter, suppose my U is only KPES. Now if my U is only KPES, how do I tune this KP? I will simply change my KP and I will be analyzing my output, and finally wherever I get the best output, I'll choose that KP. But if I am having 2 parameters, then how will I do? What will I do? I'll fix my KP and then I'll keep on changing KI, suppose. Then I have to, because I have to do several experiments, and out of those experiments I'll choose the best one. So then what will I do? I'll change KP to second value and then again vary KI over the complete range. Then choose KP third value and vary KI over the second complete range. Now you can see how many you are increasing number of computations. So tuning becomes complex. Now if it is a PID, then I have to tune 3 parameters. But when we do 3 parameter tuning, then what happens? There are actually in PID we have some conventional, I can say, tuning strategies, but these are only for KPKI, KD, and they work fine. But still, they are also means some calculations need to be done to find out the KPKI, KD. But if I introduce 2 more parameters, how to tune them? Means by enhancing the capabilities of my controller, I am introducing complexity into the system. Tuning becomes a problem. Now this tuning problem may be solved using the optimization techniques that also we'll see. Okay, now coming to the robust nonlinear fractional order fuzzy PD plus fuzzy I controller. Now when we are introducing fuzziness into the PID controller, and the control structure is such that its combination is made as summation of the control action of the fractional order fuzzy PD plus fractional order fuzzy I. तो आपका fractional order भी हो गया, साथ में fuzzy भी हो गया. So 2 capabilities introduced into my PID controller. So the controller will be enhanced, but again it's a complicated sort of thing. So fractional order fuzzy PD is obtained from conventional fractional order PD. So I'll get a fractional order PD and then I'll fuzzify the things. Then fractional order fuzzy I can be obtained from fractional order integral controller. And finally, the overall control action is the combination of the 2, means you can add the 2 control actions. So your UPD will be obtained like this, where PD means PD controller. So KP for PD controller, KD for PD controller, and it's a fractional order, so S raised to the power lambda. And finally, by doing the backward transformation and the mathematics involved, we are able to derive the control law for the fuzzy fractional order fuzzy PD plus I, and which is here. Okay. So those who are interested in working in this area, they can see the literature. Everything is given in the literature. Here I'm not discussing details of this. So this control law which we derived here can be simulated using the Simulink or the block diagram for the control structure is given like this. So here you can see it's a desired trajectory, and this nonlinear system represents, means here we will have a robotic manipulator and the output will be compared with the desired trajectory, and accordingly the control action will be done, and the input to the motors will be given accordingly. And then the fuzzy logic design. So we need to do the fuzzification. For fuzzification, we need to find out how many membership functions we are using. Here, actually, I think we are using only 2 input membership functions and 2 output. So rule base will also be designed, because if I go for more membership functions, then it becomes highly complicated. So we have output positive, output negative, output 0, three membership functions. So it's like this, the rule base. Then the actually this fuzzy is formula based fuzzy. So we use a formula, and then the fuzziness means is introduced into the control action. Then the 2 degree of freedom fractional order, fuzzy PD. So in the previous one we did fractional order, we did fuzzy also. But now we have introduced fractional order, fuzzy, as well as 2 degree of freedom. But here it's only a PD controller. So 2 degree of freedom introduces, actually why do we go for 2 degree of freedom? It actually allows us to handle both the things. One is set point tracking and another is disturbance rejection problem. So both the problems can be handled simultaneously. Otherwise your 1 DOF controller, when tuned to a certain value, will be able to handle only this, or when tuned in another manner, it will be able to handle only the disturbance rejection. Both cannot be handled simultaneously, but if it is 2 degree of freedom, it gives us this flexibility also. Then again, the 2 degree of freedom fractional order fuzzy PD derived from 2 degree of freedom and fractional order, and then also the fuzzy. So again, the control law is derived. This is the block diagram model of the control structure of 2 degree of freedom, fractional order, fuzzy PD. Then we have fuzzy logic design, again the input output membership functions defined, and then these regions are defined, IC regions are defined, and finally means the logic behind this is evaluate input combination regions. These are input combination regions, and for that, what will be the output? If this is the input combination region, I see 1, 2, 4, 5, 6 in 1, 2, 4, 1, 1, 1, 1, 2. 5, 6. This is 1. So 1, 2, 4, 5, and 6. So when it is in this condition, if your inputs lie in these regions, then this should be your control output or control action. Okay. So accordingly, we derive it. And then the Lyapunov criteria is also introduced into the controller. And we know that Lyapunov is for maintaining the stability of the system. So to ensure the stability of the complex coupled system, we can means when this condition is always met and the control action is designed in such a way that it's met, and you're always in the stable region. So you will have a Lyapunov function, and that we know that 3 conditions of the Lyapunov function need to be met. So these are the 3 conditions which should meet, and finally a Lyapunov function is chosen where epsilon is the error, actual and desired actuator angle. So, and this is the actual and desired actuator velocities. So error between the angle and the velocities is the input to the Lyapunov function. Then it's fuzzy also. So Lyapunov plus fuzzy, accordingly the rule base is designed, and this one shows the schematic diagram for the Lyapunov, linguistic Lyapunov fuzzy controller, where you will provide a reference trajectory. You have to do the inverse kinematics because a reference trajectory will tell us about the position of the end effector. So from the position of the end effector, we want to know what should be the values for the different angles. So that is done with the help of the inverse kinematics. And then those from the inverse kinematic, the angles which we are obtaining are the desired angles of the different joints, and the actual angle of the joints can be measured. Then the error between the two, the error is modified, and means the controller part, LLFC controller, and then the control action goes to the Maryland manipulator, means to the motors of the manipulator. And we know that even this linguistic Lyapunov fuzzy controller has introduced more number of tuning parameters. So these are the tuning parameters which we need to do, and it's a fractional order. No, it's not a fractional order, I think. So these parameters need to be tuned, and the parameters are tuned using the most commonly used optimization algorithm which we found, or it's actually multi-objective, and it has you can say it's quite strong optimization algorithm called as NSGA2, which is called as non-dominated sorting genetic algorithm, and its version is 2. So it's NSGA2, and it's a multi-objective optimization algorithm, and it gives us multiple solutions. So Pareto front are given, and from those multiple solutions you can choose one. So as I told you, it's a non-dominated sorting GA, and it's highly powerful optimization technique, and it's multi-objective. Means actually what happens when you go for multi-objective using normal single objective sort of optimization techniques, then how do you proceed? For all the objectives, you put a weight to that. So suppose I have two objective functions. My first objective function, I'll give weight 0.5. To my second objective function, I'll give weight, suppose 0.5. And then I'll add the two. So weighted objective function means multiple objectives are converted into single objective using the weighted objective function. And then it is optimized using the normal optimization techniques. But this is not done in non-dominated sorting GA2. Here we we find out all the solutions such that my one objective function is also minimized, and another function is also minimized, and I'll get multiple solutions, and out of those multiple solutions I'll be able to choose the one. So when coming to the results, actually all simulations are done in MATLAB in this part of work, and it's only just 4 GB RAM. And what are we comparing? We are doing the evaluation, the results of two-link robotic manipulator using fractional order fuzzy PT plus I, and compared with the conventional techniques. Then again, two-link robotic manipulator with 2 degree of freedom and fractional order also fuzzy PT, and Maryland manipulator LLFC. So when we want to do the analysis of any controller, we will be doing it on the basis of different, you can say, sort of analysis we'll be doing. One is simple trajectory tracking performance. I give a trajectory and I check whether my robotic manipulator is able to track that trajectory or not. Then what happens, because when you model a system, there may be, we can say, errors while finding out its parameters. So you do not know the system parameters accurately, or sometimes what happens, the system parameters may change. So in that case, if there is uncertainty in the system parameter, then that analysis also needs to be done. So it means if my parameters are changing, or if there is inaccuracy in finding out the system parameters, then also my controller should behave efficiently. So that analysis is also done. Then varying boundary conditions. So because what are the different boundary conditions which I am supplying. If that boundary conditions are varying, for trajectory means my trajectory is also varying, and my disturbance rejection, that is also, disturbance is also varying, and means I'm doing trajectory, I'm doing disturbance rejection with and without parametric uncertainty and plus the varying boundary conditions. So different you can say changes are made here. As I told you, we are doing the trajectory tracking performance, we are doing the disturbance rejection performance with and without parameter uncertainties, and also with the varying boundary conditions. So the trajectory tracking can be done using any of the techniques. So here we have assumed this as the polynomial to define the trajectory, and a schematic diagram for the 2 degree of freedom robotic manipulator. Here you can see this one is showing the robotic manipulator, and here I am getting in as tau 1 and tau 2, and output is my theta 1 and theta 2. These theta 1 theta 2 are compared with my reference trajectories कि मेरा theta 1 कैसा होना चाहिए था, वो वैसा है या नहीं है, means what this is my actual theta 1, this is my reference theta 1. So if there is error, then accordingly these are controllers, and accordingly the controller will give input to the, and controller plus the, you can say the dynamic model. So all these will finally give me the torque, calculate the torque depending on the dynamics, and the torque will be then given to the system, and when the torque is given to the system, it rotates. So this is how it works. So these are the different results. As I told you, Pareto front, what happens, here you have one objective function, here you have another objective function. One object, if I consider this solution, then my objective function, if this is 1, this is 2, then at this particular condition, my objective function 1 is minimum, but objective function 2 is very high. If I take this condition, then my objective function 1 is not minimized, it's high, but my objective function 2 is minimum. So I'm getting multiple solutions. All these dots are the solutions. So out of all these dots, we are going to choose the best one, and you will see that the one means I can choose this one, I can choose this one. So here also I can see that both are being minimized. Here also, so these two conditions, these two are the positions where I'm getting both as minimum, but for this work we found this to be more suitable, and this solution is being used. Now when I do the after doing, means if I'm choosing this solution, then according to this solution, the values of the kp, ki, kd, kp, ki, kd for link 1, then kp, ki, kd for link 2, then the other parameters which we use, k1, k2, ku, pd, ku, lambda, l1, all these optimized parameters. After obtaining these optimized parameters, we will run our system by giving these, setting these optimized parameters in the system. And when we run that system, the error between the actual trajectory and the desired trajectory, and integral absolute error. So if we do this, then the last row of the results show us the integral absolute error, and here you can see the results. The first one, this portion, is the result for the link 1, these are the results for the link 2, and in case of link 1, if it is a normal PID, it's 10 raised to power minus 3, but 7. When it's fractional, when it is fuzzy PD plus I, then it is again reduced. But when you have fractional order as well as fuzzy, then it is reduced to quite a large extent. And these W1, W2, these are the objective functions. So this is how we do, and the results are also given when we actually reference tracking performance. The plots here are actually, it's not, if I zoom it, then it will be having, even this one will be having many plots behind it, but we need so much accuracy that when we plot it on a scale like this, then all of them seem to be overlapping each other, but they are not. So different types of controllers, fractional order, fuzzy PD, uh, fuzzy PD plus I, PID, link 1, so on. Okay, so these are for link 1, these are for link 2, and what is this? The plot is for the angle of the links. Okay, and this one is the error in the links angle. Okay, this plot is for the controller output. What is the controller output? Means what is the input going to the motors, and this one, this fourth plot is for the location of the end effector, how our end effector is moving. Seems to be stuck. So next one is the robustness analysis. As I told you that when we design any strategy, we have to do the robustness analysis. And in case of robustness analysis, we can do model uncertainties, we can do disturbance rejection, and we can vary the trajectory also. Then these are the results when we have model uncertainty. What are the model parameters where you can have uncertainty? Mass, the length, you know? Mass and length are the two parameters, and they are increased or decreased by some, suppose 15% plus minus, and accordingly in one experimentation we changed only mass M1, then in another we changed M2, in third we changed M1 and M2 both, then again for L1 only, L2 only, L1 and L2, and the final experimentation is when you have all the four parameters varied plus minus by 15%. And here you can see when if it's a PID controller, then the changes are quite large, means when uncertainty introduces, the performance of the PID controller varies. Whereas for the blue one, you can see it's quite stable and it comes out to be a quite straight line for all the four types of experimentation which we have done. Then for the disturbance, we said that we may have cogging, we may have eccentricity. Due to this, that we have sinusoidal error. So we introduced the sinusoidal disturbance into the system and we analyzed it. Finally, it was found that your fractional order fuzzy PD plus I shows the best results. And even disturbance rejection along with the parameter variation, I think model uncertainty, both are done. Then for varying the reference, when your reference trajectory is varying, the trajectory is highly varied, means the boundary condition for the trajectory are varied, and accordingly the controller performance is analyzed. Again, we found that the controller performance for fractional order fuzzy PD plus I was quite good. Then the experimental validation, because we said that when I want to control a robotic manipulator, the precise control of motor is required, servo motor. So you may use a DC servo motor, and the evaluation part was done on the lab setup of DC motor. And again, the different types of controllers were done to evaluate the behavior performance of the DC motor. Then the two-link manipulator control using non-linear 2 degrees of freedom. Again, the controller which we discussed was simulated in Simulink, and then the results and the analysis, everything was done, and it was found that 2 degree of freedom fractional order fuzzy PD was showing good response, even for noise suppression also. The disturbance rejection, all analysis was done. Then for the Maryland manipulator, it's again, as I told you, even two-link manipulator was quite simple, but still it's not that simple. But Maryland is a highly complex non-linear coupled system, and it operates under different conditions. So we need to have a stable system, stable controller, so performance must be stable. So LLFC controller, fractional order fuzzy P, fractional order fuzzy PID, and fractional order PID controller. It's fractional order fuzzy P minus fractional order fuzzy PID. It's minus again here. Actually, the control action is combined by a minus sign. And these are the trajectories which we followed for Maryland manipulator. Again, these things, most of the things were taken from the literature, and the new controllers were designed and the performance was compared, and robustness analysis also done again in the similar direction. So finally, to conclude, we can see we designed fractional order fuzzy PD plus I, 2 degree of freedom, fractional order, and then fuzzy and PD. So all these combined, or Lyapunov, linguistic Lyapunov fractional controller. So all these controllers are successfully implemented, and the performance is tested against the conventional controllers or the controllers which are already existing in the literature. And the experimental study was performed on the DC motor, and robustness analysis was also done, and it is seen that the performance of the different controllers is highly, you can say, it's very very good, and the performance is validated. And then the results, it is also revealed that controller performs efficiently, and it provides accurate and tight positioning control, and robustness, the controller was found to be robust. So that's all, means how we can do research in the area of the robotic systems. So if you have any queries, I'm there to address them.
Any queries from the participants? If you have any queries, you can ask right in the chat box. Okay, thank you very much, ma'am, for the wonderful lecture, and it will be very beneficial for the participants who are working in the area of robotics. And thanks for all the modeling that you have shown. It was very beneficial to all the participants. And I thank you. Once again, thank you for sparing the time. And we hope that we will continue the series of lectures more. Thank you very much, ma'am.
Okay, thank you, madam. Thanks a lot to all the audience for listening to me very patiently, and I hope that this will be beneficial. Thank you.
Thank you, participants, and thank you, ma'am. All the participants, you can leave now. Tomorrow we will be meeting at 9 o'clock. And tomorrow there will be a valedictory session, and afterwards there will be a small test that will be based upon the sessions that we had heard.